Okay, so think about this. You have an order placed in your application. You need to charge the user, update inventory, send a confirmation email, and log it for analytics all at once. So, what is the obvious way for this? Call each service one by one, but your checkout endpoint is now waiting for the other four systems, right? So, if any one of them is slow, your user is staring at a spinner. So, that's the problem event driven architecture exists to solve. Instead of asking, you announce. You fire an event and move on. So, let's dig into how that actually works. Before we go further, let's make sure we are on the same page about what an event actually is. So, an event isn't a command. It's not saying go do this. It's a record of something that already happened. Order placed, payment failed, user signed up. It has three things: what happened, who it involved, and when. And here's the thing that really matters: events are immutable. You don't update them, you don't delete them, they are just facts. That distinction is going to matter a lot when we get into event sourcing. Now that we know what an event is, let's see how they travel between services. Alright, so PubSub, which stands for publish subscribe, is the foundational pattern here. Think of it like a postal system. A publisher drops a letter into a mailbox labeled order placed. It doesn't know or care who picks it up. On the other side, any service that subscribes to that topic gets the message. Your email service picks it up, your analytics service picks it up, your inventory service picks it up. They all work independently in parallel without knowing about each other. The broker in the middle, something like Kafka or RabbitMQ, is basically the mailroom. And the reason this decoupling is so powerful is that adding a new subscriber never touches the publisher's code at all. But PubSub by itself doesn't tell you anything about your system's history, right? That's where event sourcing comes in. Okay, so PubSub isn't magic. There are a few sharp edges you need to know about. First thing, message delivery guarantees. Most systems offer what's called at least once delivery, meaning a message might actually arrive twice if there is a network hiccup. So your subscribers need to be idempotent, which basically means handling the same event twice should produce the same result. Second thing is ordering. If your subscriber gets order shipped before order placed, you've got a problem. Some systems like Kafka preserve ordering within a partition, but across partitions, you're on your own. So these aren't the reasons to avoid the pattern, they are just the trade offs you are signing up for when you go this route. Alright, PubSub moves events around, but what if you want to use those events as your source of truth? Here's where it gets really interesting. Normally, when a user's bank balance changes, you just overwrite the number into a database and you lose all the history. Event sources flips this completely. Instead of storing the current state, you store every event that led to it. Account opened with $200, withdrawal of 20, deposit of 50. Current balance is just what you get from replaying all those events. It sounds like more work, and yeah, it basically is, but you get something incredible back: a complete audit log and also time travel. So you could ask, what did this account look like 3 months ago? And also the ability to replay events to rebuild state or populate a brand new system. Event sourcing is powerful, but reading from it can be slow if you're replaying thousands of events every query. So the solution for this is CQRS. Let me give you three concrete scenarios where event sourcing actually shines. One is compliance. In finance or healthcare, you need to prove what happened and when, and a complete event log is exactly that proof. Second is debugging. Ever had a production bug you couldn't reproduce? With event sourcing, you can replay the exact sequence of events that caused it. Three is system migration. Need to move to a new service? Replay the event history into the new system and it just catches up. These aren't hypotheticals either. Companies like Axon and a lot of fintech products are built entirely on this model. But there's one problem. You have a log of events and now queries get complicated. So here CQRS is the answer. So CQRS stands for Command Query Responsibility Segregation, which is a quite mouthful, but the idea is actually pretty simple. Your write side and your read side have different needs. Writes need strong consistency and validation. Reads need speed and data that's already shaped for the UI. So why force them to share the same model? In CQRS, you basically split them. Commands go to the right side, they validate and apply business rules. Events from those commands then update what are called as read optimized projections on the read side. So your database query never touches the write store at all. It hits a pre-computed, faster read view instead. CQRS and event sourcing are often used together, so let's see exactly how. When you combine CQRS and event sourcing, this is what the full picture looks like. A user sends a command, let's say he places an order. The command handler validates it and writes events to the event source, and those events get published to the event bus. A projector picks them up and updates a read optimized view, maybe a denormalized summary table. When the user queries for their orders, they hit that particular read model directly. It's fast and it's pre-computed, so no joins are actually required. The write path and read path are completely independent, so you can scale them separately, optimize them separately, and even use different databases for each side. Let me show you a real scenario. Imagine building a food delivery app with all three of these patterns. Let's make this concrete. So you're building a food delivery application. User taps order. Your order service emits an order placed event to a Kafka topic. And three subscribers wake up independently. Payment service charges the card and emits payment confirmed. Kitchen service starts a preparation. Notification service fires a push notification. And the whole checkout path is non-blocking. So your order service already returned a 200 OK before any of that happened. And meanwhile, those events are also stored in your event log. So your dashboard read model is a projection that aggregates them. The user sees live order status from the real model. Everything is asynchronous, decoupled, and independently scalable. Awesome. Now, how do you pick a message broker? Let's look at Kafka versus the alternatives. You've got a lot of choices here. Kafka is the gold standard for high throughput and event replay. It's basically a distributed, durable log, but it's also operationally complex, so you've got to be ready for that. RabbitMQ is a bit simpler and great for traditional task queues. AWS, SNS, and SQS are fully managed, so you're not running anything yourself, which is great for teams that want simplicity over control. Google PubSub is similar to GCP World. Really, the decision comes down to one question: do you need an event replay? If yes, go with Kafka or something Kafka compatible like Red Panda or something. If not, managed solutions are usually the better trade-off. Okay, so we've covered the what and the how. Let's talk about the failure modes, as in what actually goes wrong in practice. Event-driven systems fail in specific ways you should know about. First is the poison pill message. This is one malformed event that crashes your consumer every single time it tries to process it, causing an infinite loop. So the fix is a dead letter queue, and I made a separate full-fledged video about it, and I will leave the link of the video in the description below. Check it out if you're interested. So basically, in a dead letter queue, after a certain number of retries, the message goes into a holding area where you can inspect later on, where one event triggers another, which triggers another, and suddenly you have cascade of millions of events. You handle that with back pressure mechanisms and circuit breakers. Next is the out of order events, like receiving order cancelled before order placed. So you deal with that using idempotency keys and sequence numbers in your events. None of these are deal breakers, but you do need to design for them deliberately. So when should you actually use all of this? And when is it an overkill? Here's the honest take on this. Event-driven architecture adds real operational complexity. So before you adopt it, ask yourself a few questions. Do multiple downstream events react to the same business event? Are you in a regulated industry that needs a full audit log? And do you have high write throughput that a single synchronous path just couldn't handle? If the answer to those is yes, EDA really pays for itself. But if you're a three-person team, building an internal tool or a simple CRUD application, a monolith with a transactional database is probably the right call. Don't let the hype push you towards a distributed system before you actually need one. Now let me show you how all the three patterns like PubSub, event sourcing, and CQRS relate to each other. So before we wrap up, let me give you a mental note that ties this all together. These three patterns are not a package deal. You can actually use each one of them independently. PubSub is like just like a communication. It's how events move between services. Event sourcing is about persistence, storing what happened instead of current state. CQRS is about access patterns, optimizing reads and writes separately. But here's the thing, they compound. PubSub plus event sourcing gives you an event-driven persistence. Event sourcing plus CQRS gives you the fast projection-based reads. All the three put together is the full event-driven stack that you see in systems like Shopify's order pipeline or Uber's trip management. All right, let's summarize it. Event-driven architecture is really three ideas working together. PubSub, your events communicate by publishing and subscribing to events, no direct coupling between them. Then we have event sourcing, that is instead of storing current state, you store the events that created it and you get a full history and full auditability. Then we have CQRS, that is reads and writes use different models that are optimized independently. Together these give you systems that are scalable, auditable, and resilient by design. So that's about it for this video. I'll see you in the next one. Subscribe the channel and thank you.